SMS College of Pharmacy and Health Sciences in Department of Pharmaceutics. Today we are going to see the topic of methods of analysis of complexation. Job's method of continuous variation. As per the job, the species possesses several characteristics that are dielectric constant and refractive indexes. Next one is spectrophotometric extrinsic coefficient. That is when there is a no compensation between the species, the value of property is additive. On compensation, this property changes, but additives rule do not hold good. The changes in the characteristics proves that the compensation has been taken places. Let's take two species A and B whose individual dielectric constants in solid form and absorbance in solution form were measured. The two species in both forms were mixed, the dielectric constant and absorption were determined. The individual values are substituted with mixed additives values and the results was found out. If the result is 0, then no compensation, and if the result is not 0, then there is a compensation. Another one is pH titration method. The method is applicable for the complex that produce the changes in pH on interaction. The significant changes in pH will determine that compensation has been takes place. Let us take 75 ml of glycerin solution and it's titrated with a strong alkali sodium hydroxide solution. The pH was recorded. A graph was drawn between pH and volume of sodium hydroxide when added. In another test, complex solution of glycine and copper salt is titrated. The changes in pH with increments of sodium hydroxide solutions also recorded. A graph was drawn between pH and volume of sodium hydroxide added. The two plots are compared and it is seen that the plot of glycine with the copper is well below that of the pure glycerin, which indicated that compensation is obtained throughout the titration range. Next one is distribution method. In this method, distributing a solute between two immiscible solvents can be used to determine the stability constant for certain complexes. The distribution behavior of solute between two immiscible liquids is expressed by distribution or partition coefficient principle. When a solute complexes with an added substances, the solute distribution pattern changes depending on the nature of complexes. The compensation of iodine by potassium iodide, I2 plus K, potassium and iodide, it will give a potassium plus iodide. The equilibrium stability constant K equal to K plus iodine, potassium plus iodine divided by potassium and iodine. The distribution coefficient of iodine between disulfide and water is 625. The K value of iodine potassium iodide complex is 954. The changes in distribution coefficient proves that the compensation has taken place. Solubility method. When the component is a mixture produce a complex, the solubility of one of the components may be increased or decreased. The change in solubility is a sign of compensation. The experimental data can be used to analyze complexes in terms of donor-acceptor ratio and equilibrium stability constant. Example, BABA and caffeine and paracetamol. Caffeine. Spectroscopy method. The study of donor acceptor, that is DA, or change transfer compensation is generally undertaken with absorption spectroscopy in the visible and UV region of the spectrum. D is a donor acceptor and K2 is a potassium iodide. Where D and A represents electron donor and acceptor, K1 and K2 are the interaction rate between the constant. K equal to K1 by K2 is equilibrium or stability constant for compensation. The absorption of A of the charges transfer bond is measured at a definite wavelength and the constant K is obtained for the Benz's-Hildebrand equation. Where D and A represents electron donor and acceptor, K1 and K2 are interaction rate constant. The absorption of A changes the band is measured at a definite wavelength of the constant K is obtained for the Benz's-Hildebrand equation. A0 and A 1 by summation K A and O, AO and DO are the initial concentration of acceptor and donor species in mole per liter. E is the molar absorbability of the charge transfer complexes at its particular wavelength, and K is the stability constant in liter and mole. A plot of A1A versus D0 result in straight line with the slope of 1 kE and an intercept of 1 by E. The spectrophotic method used to investigate the interaction of nucleic acid bases with the catechol, epinephrine, and isoprotanol. Thank you.